All right, we are starting part 2 of our video over, 13.2 exponential decay, right? All right, here's where we left off. We want to be able to write an equation given some points from a graph. So what we determined already is that because we know the horizontal asymptote is y equals k, that k equals 4. And our sense check here is going to be, we realize this is reflected over the x-axis, so a should be negative, right? Hopefully it's negative. So our first reference point is negative 3, 1, right? And that reference point, oh, I gotta itch my nose, is supposed to be h, a plus k. Well, gang, we have pretty much everything we need to know now because we already know k. It's telling us that h equals negative 3, right? Then we can solve. So if a plus k equals 1, and we know k is 4, so if we subtract 4, a equals negative 3, right? Now, we have everything we need, but we're going to take that second reference point and we're going to check things. We're going to make sure it works. So our second reference point is negative 4, negative 2. And we're going to equate that with what it looks like in terms of variables. Actually, we can't write the equation yet, can we? We have a, h, and k. We don't have b. We don't have the b right here, do we? Up in this equation. So we need to do this second point to get b. All right, so let's plug in what we need. H minus 1 is negative 4. That one doesn't tell us anything new. We already know that. But now this one, negative 2 equals a is negative 3 over b, k is 4. So now we're going to solve, right? So I'm going to kind of go this way. If I subtract 4 from both sides, this is what I get. And I can cross multiply here, can't I? Negative 6b equals negative 3. Divide by negative 6. b equals 1/2. All right, so here's our final equation. G of x equals, where's our a? Negative 3. Oh, thank goodness it was negative, right? We said it better be negative. B is 1/2 x minus h. We said h is negative 3, so x plus 3, and k is 4, plus 4. So I believe that's what we got. Now, let's talk about domain and range. Domain is always all real numbers, isn't it? Now the range here, because this is reflected, gang, k is still important to us, right, which is 4, but now our range is from negative infinity, right, up to 4. So we got to watch the range on these. Let's try another one. We're going to do the same thing. We have 2 reference points. Excuse me, please. So we know we can find k from the asymptote. All right. K equals negative 1. We got a negative 1 asymptote here, don't we? Okay, our first reference point is 2, negative 1/2, isn't it? Remember, this is the point that would correspond to 0, 1 on the parent graph. So that's how we're going to pick the first reference point, right? This is the first reference point because if we move this graph, that is the 0, 1 analogy, right? So here's our first reference point. And we said the first reference point is equal to h, a plus k. All right, well, we got k. H then equals 2. Okay, that's an h. Now, negative 1/2 equals a plus k. I don't know why this is doing this, but we know what k is. K is negative 1/2 equals a minus 1. We're going to add 1 to both sides. So a equals 1/2. Okay. So we have A, we have H, and K. But remember, we said we don't have B. We don't have the B right here, do we? So we have to use the second reference point to help us get B. So the second reference point is 1, 4. And that is, right, the same as H minus 1, A over B plus K. All right, let's look at our H. H is -2. -2 minus 1 is 1. So we sense check that. So let's set this. 4 equals A is 1/2 over B plus K. K is -1. So now we're going to solve. Add 1 to both sides. 5 equals 1/2 over B. So what if I write it like this, folks? 5 over 1. Right? Now I can cross multiply. This becomes 5b equals 1/2. Let's divide by 5, which is the same as multiplying by 1 over 5, right? B equals 1 over 10. Okay, let's write our equation. G of x equals A is 1/2. B is 1/10. Where's H? X minus 2 minus 1. All right, so on your own here, I'll give you 15 seconds to write the domain and range. Okay, domain is all real numbers every time. Anytime you have an exponential, right? Now look at your range. This is not reflected. This graph approaches the asymptote, never hits it. So our range, remember, our range has to do with K, -1 to infinity. Okay, so these two problems are maybe the most challenging, but just rewatch them, stop them, and try to do it yourself, and then see if you get the same answer. All right, now we're going to look at modeling. So this is a decay model where we lose some percentage of the original value every year. This is going to be a decay general formula that we'll use. You will be provided this. So A is always the original value of whatever you're talking about, okay? R is the decay, the rate of decay. It's usually in percentage. You would change it to a decimal. T is going to be years. So here it says the value of a truck purchased for new decreases by this much per year. We're going to write the function first and we'll graph it. So here's our function, f of t, right? So A is this, the original value, 1 minus 0.095 raised to the t. Okay? Now, obviously you can simplify that if you want, because this is a value between 0 and 1, which means this is going to be a decay situation, isn't it? So I'm going to graph this, right? And when we're graphing, t is our input. So that's really x. When we graph it on our calculator, it's going to look like x, isn't it? Okay. So I'm graphing it. Oops. Now your window is going to be a little messed up because we got some huge number here. So what I'm going to do is I'm going to say if it starts at 2,800, right? When I first buy it, when t is 0, I'm winging this for a second, guys. Right? Its value is up here at 2,800. So I have to open my window. So I'm going to hit the window button, right? And I'm going to get my y min to be 0 and my y max to be 2,800. And I'm going to graph it to see what I see. It's thinking, it's thinking. Now notice I didn't change any of my x's. So right now, if my graph ends here, right at 10, it does something like this. I am going to go back to that window button and I'm going to change my x's because I don't need any negative x's, right? There's no negative time. So I'm going to do my x min is 0 and I'm going to take my x max out to 20 just to see what we got. So now if this is out to 20, at 20 we're down like this. All right. Use the graph to predict after how many years the value will be 5,000. So remember how I don't like the trace function? In this case, we got to use the trace function. Okay? The trace function, right? If you look at the top of your calculator and you have these 5 buttons, trace function's right here. So I'm going to hit trace. That puts the cursor on the graph. At the bottom of the graph, it's telling me what my x is and what my y is. Well, when I first put it on, just for me, I'm at an x of 10 and a y of 10,319. So I'm not anywhere near 5,000. So I'm going to arrow down the graph till I get as close to 5,000 as possible. Let's see what we got. I'm arrowing. So basically, there's a point where x is 17.12 and y is 5069. Okay, we're getting there. If I click one more time, now I'm on the other side. 1727, y equals 4992.99. So this one's actually a little bit closer to 5,000, isn't it? And we're never going to be exact. We're not going to be exact. So we are going to pick this point. As long as you're in the ballpark, gang, I'm okay with it, aren't I? I'm okay with it. As long as we're in the ballpark. So I'm doing some little finagling here. So you would say after about 17.27 years, after about 17.27, right? This is really an about years. The value has decreased to about $5,000. All right, let's see. We're going to do one more. So the value of a sports car, let's put so it looks like this. A 1 minus r to the t. Same type of problem. The value of the sports car purchased new, right? A is the original value, decreases by this. Write an exponential function for the depreciation of the sports car. So f of x equals 45000, 1 minus 15% to the t. Now it says, after how many years will the two vehicles have the same value if they're purchased at the same time? All right, here's what we do. We already have the graph of the first car that we did here, right? So roughly, right, it started at 28 and it did something like this. So we're just roughly putting it up there. But I'm going to come over here and I'm going to graph this second equation, 4,500. And this is what I'm going to get. Now, it started at a much higher value. So this graph is coming in, boom, 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 something like this, right? Because it depreciated much faster. So they're the same value right here. We're going to use the intersection command on the calculator. So I have these two graphs. So I'm going to hit second, right? And my trace button, which has calculate above it, doesn't it? And if you go down to 5, it says intersection. You hit enter.